All right, so I think this is recording. Let's take a look at this problem. They give us a function and they ask us to find the inverse and then to determine if this inverse is a function. So the original function f is, excuse me, is a quadratic function, but they have restricted the domain. So they've also given this to us in vertex form. Maybe you can see that a little bit better if we write x as x minus 0. That's being squared plus 4. Just that little rewrite helps people, I believe, to see that with this being a 1 here too, that the vertex, remember this is x greater than or equal to 0. So if we sketch this, the coordinates of this vertex is 0, 4. And we want the right half of this, values of x that are greater than or equal to 0. So with this modification, with this restriction on the domain, that changes this function to be one that passes the horizontal line test. This is a one-to-one function, and we fully expect the inverse to be a function. So let's find the inverse function then. Our technique for finding this is to switch the domain and range. So we're going to switch x and y. In the equation, I'm going to stop writing y minus, so this is just y squared plus 4. Now, the domain and range have also switched. This x was greater than or equal to 0. The domain of that, x greater than or equal to 0, you would write this in interval notation with a bracket, 0 to infinity. And the range of this, since it opens upward, it has a minimum point, a minimum y coordinate. But this range now becomes the domain for this inverse function. And the old domain becomes the range of this inverse function. So we use that range information just in a minute to simplify our expression. Oops. All right, so we're trying to solve this equation for y. We subtract 4 from each side. We take the square root of each side. We can simplify the left-hand side to the absolute value of y. But we know a little bit of information about y. We know from looking at the range that y is always 0 or positive. So these absolute value symbols are not necessary. It is necessary that this principal square root have an output that's 0 or positive. But y is always going to be 0 or positive. That's why we don't need that absolute value. So we have y is equal to the square root of x minus 4. And that's our inverse. And since we know that this inverse relation is a function, because the original function, f, was a one-to-one function. So I know that this inverse relation is a function. And I can use the function notation, call it f inverse, and it's the square root of x minus 4. The implied domain, I don't have to continue writing the domain here. The implied domain is 4 to infinity. So yes, our inverse is a function, and that's why we use that function notation. So I hope that helps, and I'll talk to you later. Bye.